Hello everyone, we are from Group 8 and then we are going to present on the SCL1, which is the topic on commercialization, strategies and benefits of biotechnology product with examples of success and failure story. I am Lame K and then my teammate is Antin Xuan, Parata and Ananda.
So first of all, I would like to introduce what is the biotech product. So biotech product is a product that utilizes biotechnology to develop and modify the value of the products for various purposes. So actually, biotech product includes wide range such as pharmaceutical, for example as vaccine and antibiotic, medical diagnostic such as pregnancy tests, agricultural sector such as the genetically modified crops with higher yield and also resistant to certain disease, and then is the industrial sector such as the detergent. So for the food and beverages such as the cheese, wine and bread, and then the other products such as the biofuel.
Now I would like to talk about what is commercialization. Actually, commercialization is a process of making a new product or service which are available for sale to the public or bringing a product or service from the development stage to the market. Actually, there are activities that require like production, distribution, marketing and sales to ensure the success on the commercialization of certain product or services.
So now I would like to talk about the factors for success in the commercialization. So first of all is the entrepreneur capability. So the entrepreneur should be able to do the market survey to determine the market potential of their product or service. Besides, they also should be able to manage the risk and troubleshoot and solve the risk. So the second one is the R&D capability. So the entrepreneur should be able to hire the qualified R&D personnel to ensure the high quality of the research and produce new product or service. And then the third one is the distinctive features. So actually, this one is very important to ensure their product or service can compete to other commercialized product or service. So in terms of technical features, flexible architecture, and also the acceptability of the product. So last but not least is the networking. So the entrepreneur should widen their networking to different sectors such as the academic, government, and industrial, so they can get the network support and the alliance from.
Next, I would like to talk about the benefits of commercialization. So first of all, benefit of commercialization is generate revenue. By bringing new products and services to the market, commercialization can boost the revenue for the companies and the organization involved. The second one is driving economic growth by creating jobs. The growth of new businesses and the expansion of the existing one can create new job opportunities in various sectors. Next one is stimulating innovation. The company will interest to produce new product due to the company can get the revenue. So the next one is enhancing consumer choices. So commercialization of new products will give more choices for the public to choose. So last but not least is address society needs. By bringing innovative products and services to the market that meet the public need and requirement. So now let us get into a story of a success biotech product which is BTC3002.
So now I would like to talk about BTC3002. So BTC3002 is a genetically modified clone which contains a gene from the bacteria which known as Bacillus thuringiensis BT. So the unique of the BTC3002 is BTC3002 can produce an insecticide protein which is the BT delta endotoxin. So this protein can cause the BTC3002 resistant to certain insect pests. And then the unique of the BTC3002 is the BT protein do not significantly affect the earthworm or other small invertebrates. So BTC3002 had first introduced and adopted in the United States in 1996. So these two pictures have shown that how the BTC3002 is developed. So scientists have
identify a gene in a soil bacterium which called Bacillus thuringiensis T. So they copy the gene in the BT and they have provide the insect-resistant trait. So the scientists use tools to insert gene into the DNA of the plant. So after that, in the laboratory, the scientists will grow the new corn plant to ensure it has adopted the desired trait which is insect resistant. So if successful, the scientists will first grow and monitor the BT corn in the greenhouses and then in small field tests before moving it into larger field tests. So the GMO plants need to go through in-depth review and safety tests before they are ready to be sold to the farmers. So now I would like to talk about the company involved in the BT corn. So actually the Monsanto is the first company that exploit in the BT corn technology, and it is credited as the first company to bring the insect-resistant BT corn to the market. So they have a product which known as the MON 810, and then their trade name is Yuga Corn Borer, and then which is at the 1997.
BT corn was first commercialized in 1996 in the US, particularly US Midwest. Its target customers were farmers dealing with European corn borer infestations. So one of the key success indicators is its widespread adoption after 3 decades, and is generally accepted in North America and parts of Asia and Latin America. Not just that, the global market size of genetic modified corn is valued as USD 268 billion in 2023, with an expected compound annual growth rate of 5.2% from 2023 to 2033. The huge global market size of genetic modified corn also indicates its success in commercialization. It's because BT corn is one of the key segments under GM corn. So why is BT corn a success story? Well, here are a few factors. Firstly, it's due to regulatory approval of BT corn by the regulatory agencies. Then, the clear and measurable value for farmers is another factor of success, whereby immediate benefits such as reduced crop losses and lower pesticide usage were experienced by the farmers. Last but not least, the effective commercial and marketing strategies, which includes demonstration trials, education and extension services, and licensing and partnerships, is the factor for the success of commercialization. The successful commercialization of BT corn have brought numerous benefits in terms of economic, social, and environmental. So economically, BT corns have increased farmers' income, reduced losses due to pest infestation, and reduced input costs due to lower pesticide usage. Socially, BT corns have reduced the need for manual pesticide application, and this improves labor safety. Not just that, it also supports food security by ensuring more stable yields. Lastly, BT corns have positively impacted the environment by reducing pesticide usage and promoting sustainable agricultural practices.
Thank you for your attention.
Now, let me tell you about the first ever commercialized genetically engineered crop, the flower-starved tomatoes. It is developed by a company called Cargill based in California. It is launched in 1994, where it was designed to solve a common problem, which are the tomatoes ripen too fast and turn mushy before they even reach the store. So what is Cargill's solution? They use a genetic engineering technique called antisense to inhibit polygalactoronase PG gene in tomatoes. Polygalactoronase PG enzyme causes softening of the cell wall by breaking down the structural polysaccharide pectin in the cell wall. So scientists at Cargill had uncovered a gene that produced a complementary mRNA to prevent PG gene from being transcribed. As a result, the tomato produced only 10% of the normal amount of the PG gene. This can delay ethylene production, and eventually it can slow down the ripening of tomatoes, and ethylene production, which can give it a longer shelf life. So the picture on the right shows the mechanism behind the fluff-soft tomatoes. So this is the timeline version of fluff-soft tomato story, where in 1992, Cargill submitted the fluff-soft tomato to the US Food and Drug Administration (FDA) for initial assessment safety aspect. It was the first genetically modified food crop ever reviewed by the FDA. So after evaluation, FDA has approved it as safe for consumption, where it leads to introduction of fluff-soft tomatoes to the market in 1994. So fluff-soft tomatoes were planted for commercialized purpose and released to the market in United States. They were marketed as tomatoes with delaying ripening and better shelf life thanks to the antisense technology that block the PG genes explained just now. However, due to numerous challenges during the period of 1994 to 1997, the fluff-soft tomato have to be officially withdrawn from the market due to numerous problems, including economic loss and market resistance. So despite fluff-soft tomato being a scientific breakthrough as the first genetically modified food, however, it failed in the market due to several reasons. First is due to consumer resistance. So many people were very skeptical about genetically modified food, which leading to the low market acceptance. During that time, public awareness about GMOs are still new and the trust about the safety was still lacking. Next is low productivity. So the crop had poor yield and also underperformed in the field compared to conventional tomatoes, which make it very unattractive to farmers. Next is lack of distinct consumer benefits. Although it lasts longer, the tomato did not taste better and was much more expensive than traditional tomatoes. So consumers did not see a clear reason to choose fluff-soft tomatoes over conventional tomatoes. And lastly is high production and handling costs. So the tomatoes were delicate and require manual harvesting and careful handling, which lead to higher operational costs.
Now, we'll see what has happened after the Calgin company could not market the Flav7 tomato. Firstly, a big firm known as Monsanto transferred to Calgin its 50% stake in tomato to a well-known distributor known as Gargilo. Then, after some time, the Monsanto bought the remaining asset of Calgin for about $240 million. This made the complete shutdown of Calgin company. Yet, Monsanto still marketed the tomato. But after a period of time, due to unpopularity of the GM tomato, the production and commercialization of the tomato was completely stopped. For Monsanto, which was a very huge agro-tech company back then, it is not a big deal and a big loss, and it started to focus on other biotech commodities and food products. Therefore, from the failure of Flav7 tomato, what we should learn is the market acceptance is important. Due to Calgin, who was not aware of the people mindset back then on GM product with high pricing, the product was not able to market it well despite by its scientific nature of being a very promising genetic modification. Besides, we should also cooperate with local plant breeders. This is because GM agriculture product can be marketed well even only if we get the support from the local farmers on the product. In Calgin case, it is not consult with any of the local plant breeders beforehand to know the market value of the Flav7 tomato. In conclusion, we can see that BT corn is an example of successful biotech-based food product, while Flav7 tomato it is not. The failure of Flav7 tomato is rooted back to its low shelf life, high production cost, and of course, the less marketing strategy. Therefore, in order to establish a successful company, we should not repeat the same mistake as the developer of the Flap 7 tomato. Here are the references that used for this presentation. Thank you for your attention.